Hi, my name is Akil. I'm one of the instructors here at Silicon Valley for You. So today what I'll be doing is introducing one of the next topics that project development students will be working on. I'll also be showing a brief visual of what one of the projects will entail. So let me turn my computer. The next set of topics that sv4u project development students will be working on is computer vision. So the whole idea is that image recognition and image processing is rapidly spreading because there is a number of different use cases that computer vision can be applied to, and they're used to enhance the quality of work in many different use cases. So I'll be introducing a few of them. One of them is scanning documents and retrieving text. Another one is image segmentation in orthopedic surgery. This is very important because surgeons are not always able to see what they are working on. In certain surgeries, the surgeon may not be able to make a certain cut, and therefore they have to kind of feel their way around with their medical devices, and this sometimes leads to mistakes. So the idea is that if a surgeon can attach a camera to their device and in real time detect the different organs and blood vessels and arteries, it would help them and decrease the chance of a mistake happening. Another use case is tracking movement at a microscopic level. So scientists who want to examine and kind of keep track of the movement of a cell or even parts within a cell. And a big one today is self-driving cars. So as you guys know, with a self-driving car, you have to detect other cars, you have to detect the lane, you have to detect people, you have to detect the traffic symbol, and this is all in a very rapidly changing input based on the environment. Another use case is monitoring traffic data. So obviously, these are just a few of many, many use cases that computer vision can be applied to. So one of the biggest and most important things in computer vision is understanding the environment that you are operating in. So students will be working on real-time detection and real-time image processing, and they'll be using a multiple different algorithms. So they'll learn about thresholding, edge detection, and boundary detection. So some of these are described here: thresholding, image segmentation, and contour detection. Something that's very important is that um, the software has to be able to reconstruct a 3D image based on the changing input. So obviously in any environment, self-driving cars or surgery, the environment is going to, the image is going to change based on the surgeon moving their device and thus the camera moving. So the software has to be able to reconstruct this image without changing the output. So the technology that students will be using, all the students will be using Python. Within Python, there's multiple modules that they can use: OpenCV, NumPy, SciPy, and scikit-image. They also have the option to train their own neural network using deep learning. So the first project that I will be showing is basically using image processing to outline the position of the gallbladder in a patient during prostate surgery. These are some of the current projects that students are working on, and I'll come back to these a little later. So what I'm going to do right now is just pull up. Yeah. Okay, so I'm going to run this code real quick so that, oh wait, this is the wrong. Okay, so this one right here this is basically a 3D image of exactly what I showed before of a this was taken during a prostate surgery. So just by visually looking at this, you can kind of see that the gallbladder is right here, and is the brightest. It has the brightest pixels. So when looking at it, you can kind of think that you could do some sort of thresholding to segment out the brightest pixels. You can also do contour detection in this case to identify where this gallbladder is located. So this is one of the projects that students will be working on uh, using image processing and possibly deep learning. So the second thing I wanted to show is a so this is another set of images from the same patient. So in this case, you can't really see the gallbladder. So for this situation, students have the choice of either classifying these images or clustering. So basically, supervised or unsupervised learning to cluster these images into images with the gallbladder and images without the gallbladder. And then from there, they can take the images with the gallbladder and use image processing techniques to segment out and identify the exact X, Y, and Z coordinates of the gallbladder in this case. So I'm also going to, so these are some of the current projects that students are working on. Um, the students are currently working on data analysis projects. Um, so what this process entails is taking data from a file or taking data from an API and then storing the data in a database using different algorithms such as regression or classification to on this data, and then from there making predictions. So these are just 5 of the projects that are currently um, that students are currently working on. There's a few others that haven't been started yet. So the first 3 are fairly self-explanatory: stock price prediction, U.S. exchange rate prediction, and weather data prediction. Basically, taking the data and then making a prediction. And all of these projects are being developed on web portals. So the demos for these should be coming out in a few weeks. The last 2, air pollutant tracking and water pollutant tracking, are interesting projects because these are products that are not out yet. So what these do is, so the user will, these are healthcare applications. So the user can either be a doctor or a patient themselves who is trying to track what pollutants that they have breathed in over the course of their life. So obviously, not many people keep track of the air quality of the places that they live. So what this web app does is that it has the user enter their location history and the years that they lived there. It'll pull data and then give output their possible exposure to things like carbon monoxide, sulfur dioxide, and nitrate. For water pollutant, it'll track pH levels of fresh water in their areas, um, as well as bacteria and fungus and stuff like that.